trig graphs. In our last video, we had a look at the standard sine function, the standard cos function, and the standard tan function, also known as the parent graphs. And we had a look at some of the important coordinates because it's very helpful to have those so that you can then transform a graph from the parent function. So the sine graph starts at the center and then follows this wave. The cos graph is very similar to the sine graph, but it starts at 1. And then we've got the tan graph that's got asymptotes at 90 and 270. And so the period for a tan graph is slightly different. Okay. We also looked at a couple of things that can affect a graph. So the first thing was the A value here. So I've put the two grade 10 ones here in one graph. If we change the A value, it will affect the amplitude of a graph. So we could then stretch this graph out if the A value were to become 2, for example. We could also, instead of stretching it out, we could shift this graph. So let's say we shifted it 1 unit downwards. Then our function would look something like that, a little bit neater than that. And that would be then the sine theta minus 1 as a function. So by adapting the parent graph, we are making changes here to the amplitude. And then this is a vertical shift. Amplitude is the distance that a wave takes between rest and the highest point, or rest and the lowest point. Okay, and there's a formula that we could use for that if we needed to. The amplitude of a graph is maximum minus minimum divided by 2. And then bear in mind that a tan function doesn't have an amplitude because the maximum goes all the way up to infinity, the minimum all the way down to minus infinity. And so for that reason, we can't actually work out the maximum minus the minimum because we don't know how much infinity is. All right, let's move on. The next factor that can change here is we can put something in front of the degrees. Okay, so in this instance, cos b theta is going to affect the period. So this would result in a period change, and the period is the time it takes for one full wave to be complete. So here we've got the cos graph, and it takes 360 degrees for one full wave. Let's quickly jot down the periods of all of these. A sine wave has a period of 360 degrees, a cos wave a period of 360 degrees, and then a tan has a period of 180 degrees. Okay, time it takes for the function to start repeating. So there 90 degrees, there another 90 degrees, and then you'll see this part starts to repeat after we reach 180. Okay, so the period can change if we put a number in front there. So let's say we drew the graph of cos 2 theta. Then what we do is we take our period, our standard 360 degrees, and we would divide it by 2, and we'd say, well, the new period is 180 degrees. And so then this wave would literally happen in half the amount of time. And so I would actually need to draw 2 full waves in here to complete that cos graph. And then lastly, we had a look at what happens when we add or subtract something to the degrees. Okay, and this was a horizontal shift. And then just remember to think in the opposite direction. So if I were to say to you, okay, let's draw the graph then of tan theta minus, let's make it a nice easy one, 45 degrees. Then this graph would actually move 45 degrees in the positive direction. So I would then be sketching, well, I'd start actually with my asymptotes. They would move up 45 degrees. Then I'd start sketching my key points, and they would move up. And so my whole graph would now be happening 45 degrees later than what it originally started. Okay, so those are the changes that we had a look at. And then obviously amplitude is important, period is important, and then they can ask us things like domain and range. So domain would be the x values. Be careful in a tan graph, asymptotes do not count as part of the domain. They would be excluded. and then range would be the y values linking to the maximums and minimums. Now let's take some time to see if we are given a graph, can we figure out what the equation of that graph would be? Okay, so the first thing we need to do is we need to look at this graph and we need to try to decide, does it follow a sine shape, a cos shape, or a tan shape? Okay, now in this instance, it starts at the center, and so sine starts at the center, so that would definitely be my go-to thought, is this is a sine function. So let's take a moment to think about the sine graph. Okay, so the parent graph starts at 0 and then it hits 90 and 1. So if we look at this one, we should be there, but we're reaching it in half of the time. Okay. Other than that, I'm not noticing any changes. The maximum here is 1, the maximum here is 1. It's starting at the center, which means it hasn't shifted in any direction. So the period here has halved. If you have a look at one full wave, it gets completed in 180 degrees. So that means I took my 360 standard period and I divided by something to give me that new period of 180. And if you just think about it logically, 360 divided by 2 gives you 180. And this number here is always the number, or the b value, or sometimes they call it even a k value, that affects the period. So now we can say, okay, well then, therefore, this is the equation y equals sine of 2. And then we just have a look, whatever's on the axis here, this was a theta graph, so sine 2 theta. Here's another one to try. So we've got a definite tan graph here. So normally our first question is it a sine graph? Is it a cos graph? Is it a tan graph? The tan graph is very obvious to spot. So let's think about that parent function. The tan graph normally starts at 0, and then it has this key point here at 45 degrees and 1. Okay, so straight away I can see it's not starting at 0, and the key point 45 and 1 is now at 60 degrees and 1. Okay, another thing that I like to think about is the fact that my asymptotes are normally at 90 and 270. But now my asymptotes are at minus 75. This would have been at minus 90. And at 105. So if you think about it, this 90 degree asymptote, let's just focus here on the positive because that's what we've got to compare it with. The 90 degree asymptote has shifted on by 15 degrees. And my key point that I normally look at has also shifted on 15 degrees. Okay, so to me it looks like it's shifting in the positive direction, which means I need to remember to minus it in my equation. All right, then I just check 1 has stayed 1, so that means it hasn't moved up or down, and it hasn't had an amplitude change. So this is also quite straightforward. We can say y is equal to tan of, this is again a theta graph, so theta minus 15 degrees. All right, let's see if we can do this tricky one. Determine the equation of the graph below. Doesn't even really look like a graph. Hey, it could almost be a parabola, but it's got degrees here, so it's probably not a parabola. Okay, the maximum point here seems to be at 2. Let's think about whether this is sine or cos. Okay, we can see it's not tan. The sine graph normally starts at the center. So this one is not starting at the center, so I feel fairly confident to say this is going to be a cos graph. So thinking about our parent graph, let's see. It normally starts at 1. It's now starting at 2. So I think it's safe to say, if I were to guess, this graph is probably going to carry on down there and hit a minus 2 here. Okay, so that's what I'm thinking is happening. And then to try and figure out how, so I think it's safe to say the amplitude is now changing. So this is going to be a cos graph, y equals something cos, and then something. Okay, the amplitude, which is normally at 1, is now at 2. The point of rest is still at 0, so we're not going to plus or minus anything. We're just going to have the 2 cos. And now let's figure out, this is an x graph, and now how long would it take for one full wave to be complete? Okay, between minus 180 and 180, we've got a full 360 degrees there. So to do this other half, another 360 degrees there. So let's try and think. That's a 720 degree period for this graph. So I'm then going to say, okay, well, 360 divided by what would give me the 720 degrees. Okay, so this is double this value here. So that means I divided by a fraction, because remember, if you divide by a fraction, you tip in times. So if you can even check me on a calculator. 360 divided by a half gives me 720. So this graph's equation is y equals cos a half x there. Let's look at one more example that combines all of our knowledge. So we've got the graph g of x is equal to a sine a half x, and f of x is equal to 2 cos x plus b. So there I've color coded them just so that I can see. The red equation is the cos graph here, and this darker equation here is the sine graph. Okay, first question says determine the values of a and b. Now, in these graph questions, they can either ask us small letters or they can ask us capital letters. Small letters are always going to be variables within the equation. So it's their way of saying determine the equation. Whereas capital letters are going to be coordinate points on the graphs themselves. Okay, so just that's something to look out for. If you can't find A and B, check whether they are capital letters or lowercase letters. So the first one says A sine a half x. So here's our sine function, and A is going to affect the amplitude. So a sine function normally goes up to 1, 90 and 1. In this case, it's got a maximum of 2 and a minimum of minus 2. So the amplitude has definitely changed there. So I'm going to say amplitude is equal to maximum minus minimum divided by 2. And that's going to give me an answer of 2. And so I can even then say, well, therefore, g of x is equal to 2 sine a half x. And then cos x plus b, if they want this b value here, the cos graph normally starts at 1 and then goes down. Okay, in this instance, the highest point, so my maximum is normally on this y-axis. Okay, it is the graph of 2 cos, so my highest point is now going to be at 2, which should be there, but it's 45 degrees to the right. So that b value is going to have to be minus 45. So we can say f of x is equal to 2 cos x minus 45 degrees. Okay, and then just to be sure that we've answered the question, so a is equal to 2 and b is equal to minus 45. Now they say here, determine the coordinates of a and c. So they want these points of intersection between the two graphs. Okay, and when we have points of intersection, we need to set the two equations equal to each other. So let's do that. We're going to set the two equations equal to each other. So 2 sine a half x is equal to 2 cos x minus 45. Now the first thing I'll do is I'll divide both sides by 2, so that goes away. And then I'm going to change one of these sides. I'm going to say, let's call this cos, because these are co-functions. 90 minus a half x is equal to cos x minus 45. And now that they're the same trig ratio, I can then apply the cast rule. So according to the cast rule, what I want to check is I'm dealing with a positive and a positive. So where is cos positive? It's going to be in quadrants 4 and quadrant 1. Okay, so let's apply that in quadrant 1. We can just take the angle as it is. So we can say 90 minus a half x is equal to x minus 45, and then plus k times 360. K is an element of the integers. And now we can solve. So bring that other x over. We're going to have minus 1.5x is equal to, if we take that 90 over, it's going to become negative. So minus 135 degrees plus k times 360. And let's divide everything now by minus 3 over 2. So x is equal to 90 minus, that sign doesn't really matter if it's plus or if it's minus, because we're going to substitute integer values there for k anyway, which reminds me, k is an element of the integers. Okay, it's important to state that in your first and your last step. Then let's look at the second solution, which is going to be in the fourth quadrant. So we're going to take the 90 minus a half x equals 360 minus x minus 45, because fourth quadrant is the 360 minus quadrant, plus k times 360. K is an element of the integers. And now we're going to work it out. So minus, we've got quite a bit of working out here. 90 minus a half x is equal to 360 plus 45, that's going to be 405 degrees, minus x. Now, if we bring that minus x over, we'll have a half x on this side. Let's subtract 90. We're going to end up with 315 over there, plus k times 360. And then we're going to divide everything by a half. So 630 plus k times 720. Now we just want to interpret these answers. So we need the coordinates of A and C, the x coordinates there. Using this general solution, I can straight away see, oh, if I look at it, I can see that C is the point when x is equal to 90. So that's great. The 630 plus 720k, that's very big. So that's not even in our domain. So I wouldn't worry too much about that. You can obviously start substituting very systematically in here, get specific values. But let's take a logical approach. And we're just going to say, okay, at C, the x coordinate is equal to 90. And at A, over here, we are going to move, obviously 240 degrees, seems to be the repetition there. So we're going to move 240 degrees in the negative direction. So let's minus 1 times 240 and see what we end up with. X is equal to minus 150, which is completely plausible over there. So that's great. And then as a final question here, for which values of x is f of x greater than g of x? So what they're asking there is the graph of f of x, which is the cos graph, this one here, must be above, greater than, the g of x graph. Okay, so what I like to do is I like to pop some dividers in and say, okay, at every intersection, they sort of change order there. So I want the red graph, f, to be above the black graph, so not there. It's going to be this portion here between minus 90 and positive 90. And then you just have a look. They don't want them to be equal to, just where's the one above the other one. So we can then answer that and say, that was the rest of our answer there for B. We can say, well, it's between minus 90 and 90 degrees. All right, so in these cases, try to understand what they mean by this mathematical notation and how it applies to the graph. And the best way to do that, grade 11s, is to practice many past paper questions.